Hey everyone. So today we're going over for Math 6. We are going over chapter 1.1, powers and exponents. Your essential question is how can we write and evaluate expressions involving exponents? The question on the left-hand margin is what is a power, base, and exponent? So I'll go ahead and read the definition of a power to you all. A power is a product of repeated factors. The base of a power is the repeated factor, and the exponent of a power indicates the number of times the base is used as a factor. So here we have an example where the base is 3, the exponent is 4, and the power is 3/4. And what this represents is we have 4 3s being multiplied by each other. So I have 3 multiplied by 3 multiplied by 3 multiplied by 3. I know in 6th grade, this is probably one of the first times you are starting to see this dot right here instead of an X to represent multiplication. So I included over here that you can use the dot symbol to indicate multiplication, and then here's an example of when that is used. So right here I have 3 multiplied by 3 multiplied by 3 multiplied by 3. 3 is used as a factor 4 times, which is why we write 3 to the 4th, or 3 to the 4th power. And then here's a little table that can also serve as a guide. So I have 3 squared, or 3 to the 2nd power, 3 cubed, or 3 to the 3rd power, 3 to the 4th power, or 3 to the 5th power. All right, so this is how our powers and how we would say them. Next, how do you write a product as a power? And I have an example here. So writing expressions as powers. Write each product as a power. So I have 7 multiplied by 7, multiplied by 7, multiplied by 7, multiplied by 7. So I see that 7 is the only number I have here. So that is going to be served as my base. So I have 7 will be my base. Now I need to count how many 7s I have. So I have 1, 2, 3, 4, 5. So because 7 is used as a factor 5 times, its exponent is going to be 5. So my base is going to be 7, and the exponent is going to be 5. So 7 to the 5th power. And you see it closer. There it is. We're going to do the same thing for this next example. I see 12, so 12 will be my base. And there are 3 12s, so 12 to the 3rd power. Same thing with the 100. So I have 1, 2, 3, 4, 5, 6. So 100, right? And the exponent will be 6. Then we have some examples. You can go ahead and pause the video and try to see if you get correct. So I have, at this time, you can pause the video and try them. And when you are finished, you can go ahead and unpause. So now if you have unpaused the video, we're going to go over these. So I have 2, right, 3 times, and I have 6 times, and so on. So if we want to go over these a little more clearly, I'm going to go ahead and open these up in a separate section so that we can go ahead and work out these problems. So what I'm going to do is I'm going to go ahead and present my entire screen for you all. All right. So here are our problems. So I see I had a 2 as my base. Here I have a 6. Here we have 15. And then here we have a 20. I'm going to use a different color for the exponent. So here I have, now I'm going to count how many 2's I have. So I have 1, 2, 3. So that's going to be my exponent up here. Down here I have 6. So this will be my exponent. Here I have 4. So 15 to the 4th power. And down here I'm going to have 1, 2, 3, 4, 5, 6, 7. So my exponent will be 7. So this is how we are writing these. Okay, now let's go back to this right here. All right, so here's another example. What operations do powers perform on the numbers? So we're going to find the value of the powers. So find the value of each power. So I have 7 squared, which really means 7 multiplied by 7. So your answer is 49. Here we have a 5 to the 3rd power, which is 5 multiplied 3 times. But 5 to the 3rd is 5 times 5 times 5, which gives me 125. And then down here we have some examples for you all to try. I would recommend writing these out. Remember, this does not mean 6 times 3. This means 6 times 6 times 6. Or here, this does not mean 9 times 2. This is 9 squared, which means 9 times 9. Do 9 times 2, that's going to give you 18, which is incorrect. The correct answer is 9 multiplied by 9, which would be 81. And you do the same to these for these examples over here. Now let's talk about what a perfect square is. So the square of a whole number is a perfect square. Well, what does that mean? All right, let's see if we can try to identify these. Determine whether each number is a perfect square. All right, the first example is 64. Well, 64 is a perfect square because 8 squared is going to give me 64. All right, so I need a number that when it is squared will give us this number that we're looking for here. So for example, I want to know if 20 is a perfect squared. So I'm going to have to see if there's something has some number, whole number, squared will give me 20. Well, let's try 4, right? 4 squared will give me 16. Okay, that doesn't work. Let's go a little higher. 5 squared gives me 25. And that is not, right, 20. So we actually went a little higher and it did not work out. So no whole number squared equals 20. So 20 is not a perfect square. Now we can go ahead and try these. Okay, so for these examples, we have 25. So I just mentioned it earlier, but we have to try to find a number, right, that will give us 25 when it is squared. So as we know, 5 multiplied by 5, so will give us 25. So this, yes, is a perfect square. 2, well, we can try 1 multiplied by 1. That gives us 1, right? So that's not going to work out. That's going to give us a 1. And then I can go to the next one. 2 times 2 gives us 4. So I have passed this already. So no, it's not a perfect square. Let's go ahead and switch colors here. With 99, I can try 9 by 9 gives me 81. And then 10 by 10 gives me 100. And so no, that did not work out, right? 100 was too far, so that didn't work. So this one here is not a perfect square either. And then with the last one, 36, well, 6 by 6 does give us 36. So yes, this is a perfect square. So I had 2 that were, and then 2 that were not. Okay, let's go ahead and have our last example here to finish off the lesson. How can we use powers to find the area of different objects around us? So this is going to be rooted more to not just on paper, but to everyday life. How can we use it right outside of school? So you can use powers to find areas of squares. The area of a square is equal to its side length squared. So here I have, all right, a square cut off into sections. If I look horizontally, I have 1, 2, 3. So how long it is and how tall is also 3. So 3 by 3 would give me 3 squared, which is 9. So the area of this, right, square is 9 square units. Let's look at an example. Modeling real life. A life-size Monopoly board is a square with a side length of 11 yards. What is the area of the game board? So the area of the game board is equal to the side lengths of it squared. So here is an example, right? If I count the length and then square it, this is an 11 by 11 grid. So count these, I'm going to get 11 squared will give me, meaning 11 times 11 is going to give me 121. So the area of this game board is 121 square yards. Again, if you actually take the time to count them, you're going to get 11 by 11. I believe that's it for this lesson. You all can try your assignment. Now, if you have any questions, you can go ahead and let me know.